The Brookhaven Collider Accelerator Department, with the support of DOE's Office of Nuclear Physics, has successfully developed a new pre-injector system called the Electron Beam Ion Source, or EBIS. This is the first of several planned improvements to the RHIC facility. Jim Alessi explains how EBIS works.
This is an electron beam ion source, and it's called EBIS. And with this ion source, we've demonstrated a factor of 10 increase over previous sources, and now we're confident that the intensities required for RHIC can be met. So for instance, if we want to produce gold ions for RHIC, you would inject a gold 1+ ion from an ion source outside of the EBIS trap. The gold ions would be held in here, gold 1+, but then as they're sitting inside this trap, the electron beam will increase the charge state. The longer you hold the ions in the trap, the higher the charge state you produce of gold ions. So for RHIC, we would like to produce gold 32+. So you hold the gold ions in here for about 30 milliseconds while the electron beam is passing through. And then after that time, you drop the barrier on one end of the trap and the ions will stream out. And then you can accelerate them and inject into the booster and eventually RHIC. So, well, this is a prototype. We're beginning the construction of a full version of the ion source. It'll have a superconducting solenoid that'll be twice as long as this, but essentially the rest of the source, the electron gun, which is on this side, and the beam transport on this side will be very similar to what is existing here. Following the source, there'll be a radio frequency quadrupole accelerator and a short linear accelerator. Those two together will be about 5 or 6 meters long total. So it's much simpler and more compact system than what we have for the tandems.